So we're back in the cockpit with Honeycomb Aeronautical. We're still rocking the Alpha Yoke here, a little bit out of sight behind my forward control panel, but that's okay because today we're going to be focusing on its younger brother, the Bravo Throttle Quadrant. Now right off, it's probably important to say that describing this as a throttle quadrant undersells it somewhat. This is a very fully featured device, at least on paper, which incorporates not only the 6-lever throttle quadrant but a elevator trim control. We've got a gear switch and indicator. We've got an autopilot panel and indicator with a couple of knobs there and a master switch. We've got a switch panel down here. We've got an annunciator panel and we've got a flap handle up down. So more than a throttle quadrant, we've got to say. Now it looks a little bit odd at the moment for reasons, there's no levers attached. I'll come on to that in just a minute. But what can we say about this? Well, by and large it has pretty much the same form factor as the Alpha Yoke. It's a little bit unclear exactly why this has the same body size and shape as the Alpha Yoke. I mean, maybe something about a commonality of tooling or something. It's got the same flat spot on the top, but unlike the Alpha Yoke, that's not removable. So the Yoke body, I guess it's not from the same mould, but it's derived clearly from the same design. And that means this is a big thing. It's I've got it mounted temporarily in my cockpit at the moment. I've removed some of the lower panels and built a temporary pedestal for this. But actually it's too far forwards really from where it needs to be ergonomically. If I was going to mount this, or if I am going to mount this permanently, it needs to be slightly lower, and I need to make some amendments so I can inset it way into the panel. But it's really not clear why everything aft of the front panel is necessary. It's probably just a hollow shell, but it is what it is, and it mounts. I won't go through the mounting system. This is very mundane. It's exactly the same as the Honeycomb Alpha Yoke. It has a mounting plate which attaches to your shelf or the edge of a table, either using the sticky pad or using two very chunky metal steel clamps, and then the unit attaches again exactly the same way as the base plate for the Alpha Yoke. They're probably interchangeable. You could probably have one plate and mount either of these devices on the same plate. I haven't tried that. You wouldn't probably want to do that. Same look and feel. Everything is coated with this thermoplastic elastomer soft touch coating, which is great, very nice. But same reservations go that I expressed for the Yoke, in terms of how long this is going to last without becoming sticky. Time will tell, but for now it's great, and that extends to the buttons. The buttons as well have got this soft touch coat. I'm not sure about these knobs. They do feel soft, but they feel slightly different. The gear handle's just solid plastic, as is the trim wheel and the flap handle. These switches don't have a soft touch coat on them. Okay, let's talk about the levers. This is a 6-lever or an up to 6-lever throttle quad. It's got various markings on the fascia here. These are all, I guess, these look like the markings on a quadrant for a commercial jet. Now I'm not familiar with commercial jets, so I don't know what this is supposed to look like. But as it comes out of the box, each of these slots is blanked off with one of these rubber strips. So if we take one of these off, so you take that off and the slot is revealed, and then we've got the stub of the lever. Now interestingly enough, this lever has two little electrical contacts on there. We'll come on to that in a second. So I just want to show you why I haven't mounted the levers. You actually get two different choices of levers out of the box. We've got, now I'm not into these unboxing videos and so on, but I've left the levers are in these two little boxes that come in the main packaging. I suppose this is interesting. There's a touch of the Apple here. There's a little tag on here to open this, and actually that's a magnetic closure. Attention to detail, which you might argue could have been, directed elsewhere in the product. But inside the box we've got the general aviation levers, which we will be fitting in just a second, and we've also got the option of the commercial levers. So here we have levers for flying a jet or a turboprop, well, a jet most likely. We'll come back to this in just a second. But this, coming back to this electrical contact on the top of each of these lever stubs. So we take the lever, this is the throttle lever, and it's going to just slot on there. Now when it slots on there, if you look deep inside of this, on some of the levers there's two little electrical contact pins which mate with these contacts here. Now in that sense the levers have the capability to be somewhat smart, we'll call it. What that means in practice is this lever actually has a switch built in, which is probably, well in fact it is a toga, intended as a toga switch. It says on the top go around. If we look at one of the commercial levers, they have, as you will know because it's been widely telegraphed, they have a switch built in for the reverse action. Now it's a single switch, this is not an analog reverser, it's just an on-off switch. So the levers will then slot onto here. So it goes on, there's a little bit of a click as it goes home. Right out of the box that action is really nice and smooth. There's a detente at the bottom. We've yet to see if that has any significance in terms of output, or if it's just a mechanical detente. So that's interesting. I've just noticed as I take off the covers on all of these, they're not all smart levers, if we're going to call it that. Now I'm saying that because the rightmost lever doesn't have any metal contacts on. The next two have 2 contacts. The next 2 have 3 contacts each, and the outer one has 2 contacts again. So clearly there's some finesse there in what these are intended to do. That's interesting actually. I wonder, 3 contacts opens up a different set of possible functions. So actually some of these levers have more than one switch. This one's got two switches. I'm not sure what the purpose of that. There's a little red switch in there, and then you've got the reverse switch as well. So that has 3 electrical contacts on and mates with one of these 3 tag stubs. So let's go ahead and fit the general aviation levers, which is what we're going to try out first. These are, you know, basic. They're plastic. They're kind of box section, kind of hard plastic. I suppose they're reasonably robust. You wouldn't want to drop these and stand on them. That isn't going to end well. So we plonk them on. Alright, so they're the throttles. Prop controls. Again, they're kind of cheap. A little bit undersized as well if I compare these with the ones on my existing quad. But we're not going to do that. Now for general aviation, these are not smart in any sense. The only smart one seems to be the one with the toga button on. And then the mixture or condition levers. So here's the complete quad ready to go. So what we're going to do is we're going to set this yoke up, we're going to get it flying and just look at some first impressions. Now it's important to say first impressions. We can plug this in and we can immediately start flying it around using the throttle quadrant, and indeed we can use most of the other controls as inputs. Now this is an input and output device, and as is the case for all such devices, they're going to rely on specific drivers from the vendor. Now at the moment there are no drivers available for this device. They're still being constructed, and what that means is we're not going to be able to see the I believe these buttons are illuminated, the autopilot buttons. We're not going to see the autopilot buttons illuminated, we're not going to see the gear indicator illuminated, we're not going to see the annunciator panel doing anything. This is going to act as an input only device. Now the first thing I did was plugged it into Windows and verified that it is indeed a standard human interface device. So in that sense we can use it and make use of all the inputs, with the possible exception of those black toggle switches on the front. Those didn't appear in control panel. I suspect those are, as we found on the Alpha Yoke, over the 32 button limit, and they will indeed be visible in Prepared or X-Plane or Microsoft Flight Sim 2020. But we can program all of those as regular buttons and switches. They will be accessible in FSU IPC, in Lynda, in SPAD.next, etc, etc, etc. This knob here is a rotary encoder, so when you turn it to the left you get momentary closure of a particular button. If you turn it the other way you get momentary closure of another button, adjacent button. The same with the autopilot. Oh, that's interesting, that's mapped itself to something by default. The gear switch is visible, the flap switch is visible, the elevator trim wheel is a rotary encoder as well, so again when you move it forward you get multiple momentary connections of a particular button. When you move it backwards you get repeated momentary closures of an adjacent button. So again we can program that onto elevator trim or anything else we wanted. We've got a tension controller, adjuster rather, on the outside of the quad that can increase or decrease the tension on these levers in quite a limited range actually. The default tension with it all the way anti-clockwise, I mean that feels quite nice and that's fairly adequate I would think. So you can make it firmer, so that's something to play with. So just to recap, for now this is going to be usable as an input only device. We're going to be able to make use of all the features. Now this need for third party drivers is something we should probably talk about. This is something that people sometimes are not prepared for, and it's something we've seen with products from SciTech, GoFlight, VR Insight and so on. And the reality is that even when the third party drivers become available for this, like those other panels, it will only work, it can only be guaranteed to work out of the box with the standard built-in aircraft in any of the given simulators that it purports to support. So if we take Prepared as an example, this autopilot has to work using the standard built-in features of the autopilot implemented in Prepared. Now what that means is that with third-party aircraft which may implement the systems such as the autopilot separately from the built-in core functionality of whichever simulator you're using, those aircraft may not work correctly or at all with this device. Now those out there who already have the Alpha flight control system may be using the Yoke input software. Now that gives some kind of hope for the programmability of this Bravo device. The Yoke input software is written by Aerosoft, and the drivers that have been developed for the Bravo quadrant are also being developed by Aerosoft. But what Yoke input does is it gives you access to more of the application programming interface for the simulator and for the programmable parts exposed by third-party aircraft. And that just allows you to be much more flexible in setting things up. So we can have some hope that Honeycomb's driver software is going to allow us to set this up with third-party aircraft as well. We'll have to wait and see. So we're going for a flight in the Twin Otter. We've set up with the general aviation controls. I'll explain a bit more about that as we go. Let's just, I've got my parking brake on the gear knob at the moment. This is a little bit awkward in terms of the placement of this quad. Okay, I think I'm just going to stop here for a second, reposition my chair. Okay, so what else do I have set up? Well, this is going to be a good workout for this unit in general. We've got the props, we're going to have to manage the mixture controls in the Twin Otter, not going to do anything except fuel cut off, so we'll leave those where they are. Power levers, those are going to be fully functional. We've got the go around function on the toga switch, which if you watch the control panel we should get an indication when I press that. We're not going to need that, but it's on there. As I said, parking brake is on the gear lever for now. Got the heading bug on this autopilot rotary control. That allows me to, I'm going to be using the autopilot, well, let's just talk about that. I've got a full autopilot panel here, but I have set up all the buttons on the Honeycomb unit to be fully functional. That's the push buttons, so I can select the modes: heading mode, nav, approach, reverse or back course, altitude hold, indicates airspeed. Course doesn't have any meaning in the Twin Otter. I haven't set up this the mode selector. I may do that for another aircraft. That's going to be very easy to do. I might talk a bit about that later. Got the flap set up, got autopilot master switch, got the trim wheel set up. That's about all we need to know. So let's just take it off. Let's fly a bit of a sloppy circuit. We'll come back down to land. So we got takeoff power, parking brake off. Way over torquing here, so we'll just come back a bit on that power. Whoa. Got a crosswind going there, I'm not really paying attention. I'm going to go onto autopilot. I'll do that using the master switch on the Honeycomb quad, so I can go hands off now. And my autopilot over here, my panel is showing what we're doing. We're in a slight bank there, that's because we've got attitude hold on the Twin Otter autopilot. The heading bug's currently on a westerly heading. If I select heading mode, by pressing that, we should turn onto that. We've got an indicator here on my autopilot panel. What we'll also do is we've got altitude 3,000 feet selected. Let's go to 3,500. We don't have an altitude pre-select, an altitude functionality on this panel yet, although you could program that. I'm going to program that on my altitude alerter. So we're on that heading, westerly heading. I'm just going to show you that I've programmed the heading bug. If I just rotate the heading bug now on the Honeycomb unit, I sure enough turn into the left. We're going in single degrees on the heading bug, which is a little bit of a disadvantage. On my own panel, I've got a shift function. If I push and turn the rotary control, this one doesn't have a push, center push, which is slightly unfortunate. So we're doing 120 knots, coming up to 130. We want to set the props RPMs to be lower, so we're going to come back on that. So you can hear the engine note change there. Come back a bit on the power as well, I think. Don't want to go too fast. So I want to turn us to go down the road there. Alright, speed's good, we're at 75. We can cancel those heading and alt modes. Which were flight director modes. Autopilot's disconnected, but we're still getting the indications on the ADI in that direction. Windsocks showing from that direction. All the flaps. Alright, power's off. We'll try and keep it on the runway. and we're going to go full reverse. Whoa, it's hard to keep it on the runway in this crosswind. There's reverse. That's going to bring us to a stop. Okay, we've come off reverse. So that's a credible touchdown. That's pretty much a 90-degree crosswind actually. Didn't do so bad there. So there we go, first excursion with the Honeycomb Bravo throttle, general aviation, twin turboprop, twin otter with some of the autopilot functionality. We'll figure out what else to do and we'll be back. So just looking a little bit at the setup in Windows. This is Windows 7, we're in the control panel, properties, and just to run through this, all the analog axes are recognised as you'd expect. Interestingly enough, if we go through the calibration routine, I've done this already but we'll just go through once. Put on display raw data, we can see that this device is using 10-bit A to D converters. We get values between 0, 1023. So 1024, which is higher resolution than the A to D converters in the Alpha Yoke. And arguably that's appropriate because this is more of a precision device. Something else to note, although we've got a detente at the bottom of that travel of the throttle, well, of all the levers, there's no analog region below that. And actually if we go back to the button screen, we can see that if we pull the throttle lever, is the left throttle into the detente, we actually get a button click. That's just like it works on the Cytec ProFlight Yoke. That means we can use that for triggering reverse when we're using the general aviation levers. So you can see that throttle 1 is button 24, throttle 2 is button 25, prop pitch 1 is button 26, prop pitch 2 button 27, mixture 1 button 28. Now here's something, mixture 2, that doesn't seem to trigger a button. I would have expected that to be button 29. Let me just see if we can get button 29. This is the autopilot mode selector. So again you can see that's holding down button 17, 18, 19, 20, 21. The encoder for the autopilot is buttons 13 and 14. The other autopilot buttons are 1, 2, 3, 4, 5, 6, 7. The autopilot engage, button 8. The black toggle switches are, I've established, buttons 34 up, so we won't see those in this application. Gear switch 31 and 32. That's interesting, that's a dual position switch. That's not an on-off switch. The elevator trim, button 22 and 23. The toga button, toga button is 29. That's interesting. Flap 15 and 16. But there you go, we've got all the buttons and switches on the yoke, with the exception of those black toggle switches, are directly accessible. This means we'll be able to see them in FSU IPC and in Linda. Let's go and look at that. We've got Linda running, so if we go, so if I just rock some of those buttons again, this is the gear switch, so this is 31 and 32 on that particular device. That's the elevator trim up and down, which I've already mapped, you can see. Toga button, throttle detente, mixture, sorry, prop pitch detente, mixture detente. 33. Okay, so that button is working, but it's button 33. That's interesting, Linda can see that. Can Linda see? And indeed Linda can see the black toggle switches. So we're good to go. We can program anything we want. So I'm just in Linda programming up those throttle detentes to give me the reverse thrust. This is in the unsophisticated old-fashioned way of doing reverse thrust. So I've set the detente for throttle 1 to give us repeated throttle decrement command. That's how you get reverse thrust in FSX and prepared. So we'll just quickly, while that's held down, go to maximum, and then when you come out of the detente we do a throttle 1 cut, and then we do the same for throttle 2. We just record that one, FSX control, throttle 2 cut, and save that. So that gives us independent control of the reverses. So if we were to go into left reverse, there we go. Oh, we'll come out of that. So I've just done another quick experiment here. I've decided to do a little bit of programming just to demonstrate that we can pretty much use the full functionality of this autopilot, including the mode selector and the rotary control. So I've done it just for the Twin Otter at the moment, and I've hooked it up to the Twin Otter functions, but I'm programming the autopilot mode switch, which I'm just rotating here. So you can see that when it goes into alt mode, I've called a function called alt mode. We go to VS, so we're going to select a function called VS mode. I'm going to save those. So back in the sim, if we just try that out, I'm going to switch the mode selector to altitude, and then if I rotate the bug, we should see the altitude pre-select change. So there you go, I'm rotating it left, 2019, so we're going in 100 foot increments. So that's what that does. If I set the mode to vertical speed, well we're not going to see that unless we're in the air. Let's take off. So heading mode on the mode selector, rotate the bug left, there we go. Switch it back to altitude mode, rotate the bug, altitude pre-select, now 3000. If we switch to vertical speed mode, and I rotate the bug to the right, we should start to go up. Basically that's pitching us up. If I rotate it to the left, that should pitch us down. So that's that. So you get the idea. So I've been flying around a little bit more with the Quadrant. I've been using the commercial levers to try those out. I've been flying the Twin Otter, but I've set it up as a twin engine commercial aircraft. In terms of functionality, there's really very little difference. We can do everything we can do with the GA levers. The detentes have no function. We have the reversers on these two levers here. We have the addition of speed brake, which you don't need in the Twin Otter, but that can be set up as a analog control in your sim, certainly in prepared, or at least using FSU IPC in prepared. That's the way I did it. You can set up the flaps on a analog lever as well. Again, there are a couple of ways to do that in FSU IPC. I'm not sure if you can do that directly in the other sims, but you can find a way to make that work, I'm sure. Of course, you might think there's a duplication with the flap switch that we have over at the far side of the quad, which is indeed the case, but this is more appropriate positioning for a commercial or for a jet aircraft. And the advantage is that it's also a flap position indicator, so you can tell just at a glance where your flaps are set. Something about quality control. These levers, I said something about quality in terms of the GA levers. These levers are more complicated and fiddly and intricate, but they've got the same level of construction quality, which I do think is relatively low quality compared to the rest of the quad. And case in point, if we look at these reverse levers, they're spring loaded, or they're supposed to be spring loaded, so that they stay in the forward position unless you click them into the detente. Now that one works fine, this one doesn't. This on this particular lever out of the box, there's evidently some spring missing, so that doesn't stay in its home position. Now that doesn't bode well for quality control across the board, or indeed longevity of these things. These things have the feel of, as if they're not particularly going to last very long. That said, ergonomically as well, I don't like these levers. Again, I suppose something about the quality. In real life these would be made of metal, aluminium or titanium or something, and presumably they'd be pretty stiff. These are not. They're stiffish, but so for the type of flying I do, which is really hands-on, well, I hesitate to say seat of the pants flying, but very much doing manual approaches and so on, these are not the most ergonomic of levers. Now in real life, I guess if you're flying a jet in, everything's flown by the numbers and you tend to be pretty much hands off, so you're not actually manipulating the thing by the seat of your pants. So in one sense that's an unfair judgment. You'd set these, you'd have hands on, maybe fingers on, to adjust the power settings subtly as you go. But I wouldn't use these, is what I'm saying. I would use the GA levers, probably even if I was flying jets. For my money, one thing that mitigates against, if I just show you this, again the relative flexibility or lightness of construction of the levers in general. When you fly in the GA levers, they're designed in a way that allows you to grasp them with a finger between the levers. Perhaps I can show you that better if I take the levers off. So the levers are aligned like this, but you tend to grasp them with a finger in between and then move them as a unit, and that works pretty well, and it in a sense negates any lateral flexibility. So that's what it is. There is an elephant in the room which is arguably particularly difficult to ignore when you're using the commercial levers, and that is the relative layout of various things on this yoke, and notably these front panel switches and I guess the annunciators with respect to the levers. Particularly if you put the levers all the way forward, they first of all tend to obscure the annunciator panel and impede access to these front panel buttons. Now, you might argue that you wouldn't have the levers all the way forward for much of the flight envelope, in which case it's not quite as bad as you might expect. But it is an issue, it's a concession, I suppose, to the compactness of this design. To get around that using these levers, well, the vertical layout would have to be significantly increased, and there's probably manufacturing and all sorts of implications for that. Now, even using the commercial levers, the access to the autopilot panel is, in my opinion, not particularly compromised. And really with the commercial levers, it's these reverser levers on top that particularly get in the way. But flying with the general aviation levers, things are much better. The access is pretty much unimpeded in normal arrangement of the levers. You can make a case for it being slightly restricted. I suppose arguably the visibility of some people have commented that the layout of that, or the positioning of that annunciator panel, is in any case ill-conceived, because it's going to be way out of your line of sight. And fair enough, I can't argue with that, but again, it's a compromise. It has to be built into this unit. Almost by definition that unit's going to be pretty much out of your line of sight. So yes, a valid criticism up to a point, but particularly if you're flying with the general aviation setup, it's not really a big deal. So summing up, first impressions of the Honeycomb Aeronautical Bravo Throttle Quad. What can we say about this piece of equipment? Well, as a throttle quadrant alone, it's going to add a lot of value to your cockpit. The style of it is very pleasing. It uses 10-bit A to D converters, so we've got plenty of precision in terms of our settings. The lever action is very nice and smooth. It is adjustable within a certain range. It's a nice idea that we can blank off the slots that we're not using with these fairly high quality rubber strips, and they fit well. These are not an afterthought. These are good solid bungs, if you like, and of course that's going to stop the extraneous dust getting in and gunking things up to a point, because of course for the slots that are occupied, you know, most of the slot isn't blanked off, so we're still going to get dust in there, but it's going to mitigate that certainly to some degree. Arguably the next most important thing in terms of flight controls is the trim wheel. That's something that you know, we usually have to compromise on by mapping that to buttons. So it's nice to have well, it's not an analog trim wheel, it's nice to have a authentically sized wheel to map our trim to. What I found is, by the way, if you map that to single trim up and down events, this is a rotary encoder, don't forget, your trim is going to be impossibly slow, or very precise but very, very slow to trim. So it might be worth doing something like what I do, which is every time a trim down or trim up operation is detected, I multiply that by, I think, 5. So you lose some precision there, but you can trim more. You can tailor that to your own requirements. Again, it depends how you program your functions. I'm not sure you can do that natively in FSX Prepared, Flight Sim 2020 or X-Plane, but you can certainly do it with FSU IPC or Linda or SPAD.next, and maybe with the Honeycomb Aeronautical programming software when it arrives. The gear lever is, well, it's a gear lever, you know, that's arguably less, I mean, it's nice to have, but it's less of an issue if you have to have that on buttons. Again, the gear lever, okay, we've got an indicator here which at the moment isn't functional, but again, a gear lever is, you know, it is self-indicating. We don't actually need you don't practice checking for 3 greens down when you put the gear down. It's a formality. We generally don't have failures built into our sims. So the main drawback at the moment for this yoke is it's I suppose a dumb input only device until Honeycomb or Aerosoft on Honeycomb's behalf delivers the driver software. In particular these, well, the annunciator panel, which I'll say more about in a second, but more importantly, I think, for most of us, the Autopilot panel. My understanding is these, when you select a mode, that button will illuminate, and therefore this is an indicator panel as well as a selector panel. Now that might seem a small thing, but it's in practice it's a very handy thing. These legends are actually really small. I don't know how these compare with a real life Autopilot panel, but they're tiny. The writing on the text is tiny. That may be a factor for you. The annunciator panel, the text is larger. Something about this panel, you know, inevitably the more specific something is modelled in a device such as this, the less generic it can be in terms of flying different kinds of aircraft. So this annunciator panel is marked up with master warning, master caution, which are things you'll find in, you know, more complex aircraft such as airliners, probably turboprop, general aviation aircraft. I'm not sure you'll find those in your Cessna 152 and your Piper Cub. Engine fire, likewise, engine fire indicator. We're unlikely to have that in most. Well, I'm not sure about this, but general aviation aircraft. Low oil pressure, okay. Vacuum failure, okay. Low hydraulic pressure, we're not going to get that in GA. Low fuel pressure, we might get that in, you know, your Beechcraft Baron or something. Parking brake, I guess that's an on-off parking brake, that's a useful indicator. Low voltage, well, I mean, in principle, some of these indicators, they're appropriate to the aircraft we're going to fly, but, you know, the fact is, you're rarely going to get, if ever, low hydraulic pressure, vacuum failure, engine fire you might get. In this Twin Otter you get engine fire, certainly. Anti-ice, I'm presuming that's not an ice detection circuit, that's anti-ice system on. Starter engaged, you know, APU on off, so that's for your airliners or your business jets maybe. Door, not sure what door is for, is that your doors open? You get the idea, you know, this is a sort of nice thing to have. Maybe it's going to be programmable in some sense, but if we can't change the legends on those things, then even programmability is going to be fairly, well, not much use in practical terms. But as a generic programmable inputs panel, which is even without any Aerosoft or Honeycomb software, it's already fantastic. You know, you've got this array of buttons on the front which don't have legends on, which I like. I prefer that to the ones on the Honeycomb Alpha Yoke, which are marked up as specific functions. Which means if you reprogram them, you've got to stick a piece of tape over those legends. So on here, no legends. Now one thing that occurs to me is I'm not sure if these buttons are going to have any relationship to the annunciator panel, but it's interesting that there are 7 by 2 annunciator lights and there are 7 by 2 way toggle switches. So that functionality is yet to be disclosed. But again, even if these are only for general purpose use, to be programmed ad hoc to whatever you want them for, that's great. For a lot of people that's going to add value. So that's pretty much all there is to say about this. At the end of the day, this is a simple device whose primary purpose is to give you up to 6 analog inputs for your engine controls, trim switch, gear switch, flap switch, and then a bunch of buttons which are conveniently marked up for a fairly generic and fairly flexibly programmable autopilot. And I think it's going to do that absolutely fine. Looks good, feels good, a bit too big in terms of taking up desk space. The one thing I think that is a lasting criticism of this is the levers. The relative cheapness of construction of the levers in relation to the rest of the unit. In terms of the general aviation levers, they're perfectly adequate, and so the construction, with the possible exception of maybe knocking into the levers, accidentally snapping one off, which I think is a bit of a possibility. But in terms of usability, absolutely fine, no problem. Same doesn't go for the commercial levers. As I say, already out of the box there's a fault in one of them. Not as nice to hold and manipulate. But in one sense, I don't think this matters, and the reason it doesn't matter is, the fact that you can pull these off, stick them on. They've got this smart functionality built in. I predict that we've already got third-party vendors out there designing up and possibly even creating add-on levers that we can buy for this quad. Honeycomb itself, they've been very astute in making these removable in a couple of ways. The obvious way is they can sell us add-ons for. They've already got an add-on for the Airbus aircraft in the wings, if I can say that with a straight face, and maybe there'll be others to come. But I would, as I say, predict that third parties will have a field day selling into this, and they're free to make the quality as good or as shoddy as they wish, and people will buy them if they're good and won't buy them if they're not. In terms of the flexibility of these levers, it's encouraging that the stubs, I think the stubs are still plastic, but they're actually really quite stiff, which means that if someone was to make metal levers, for example, to go on here, we'd have a collateral stiffness that extends to the whole lever, and so maybe we'll see that happening. It'll be quite interesting actually to see what third parties come up with. So there we go, the Honeycomb Bravo Throttle Quadrant. This is as far as we can go with it until we get the driver software. Maybe we'll do a follow-up video when that arrives, but for now, even in its present form, driverless, and driverless is an advantage, of course. You can use this in any sim that supports a human interface device. You can program it as an input device, you can make use of all the functions. Of course, it takes a little bit of sophistication in terms of the programming and maybe a third-party tool, but that's definitely worth the trouble. As a throttle quad, excellent, very ergonomic by and large. Price wise, I think this retails for about £250, which is quite a hefty price tag for a throttle quad, but what you get for the money, it's taking the place of what you previously would have had to put together from several different products. So definitely worth a look, and there's nothing quite like it on the market. well, I was going to say in its price range, but actually in any price range, as an integrated system such as this, I think it's got very few competitors. And don't forget that Honeycomb is pushing ahead with its other systems, so this is going to be part of an even wider integrated system when they get the rudder pedals out, and who knows what else.